This is the Hero 1 robot that's been upgraded with the Hero 1 upgrade kits number 1. You can see on the top it has a new LCD keyboard display. That is attached to a Raspberry Pi 4, which is the MCP, or the Master Control Processor. I'm going to use the VEX Cortex to control its motion. The motion controller is a VEX Cortex microcontroller that's part of the Innovation's first VEX construction system. The VEX Cortex has already been replaced by a VEX V5 system, but it's still very powerful, and it's an ARM-based microcontroller, and all the sensors and motors and everything are plug and play. And I've modified it to run the Hero 1 robot motors, the stepper motors, using 3D technology. Okay, I'm going to make it move. See it moving? It's going to move forward. I can make it move backwards. And this is using Wi-Fi. It's using VexNet Wi-Fi. I can make it turn. It is very responsive. And the head can move too. Turning the head now. In addition, it can do other things such as animate the various motors, and it can move multiple motors at once. It can move the head, or the arm, or the wrist, or it can rotate the wrist while moving along. By using the push buttons on the VEX game controller that you see here, it has 8 push buttons on the front, on the top, and it has 4 on the front. Using these, I can animate the various motors while operating the robot. This is a feature that was very hard to do on the original Hero 1 robot. Multitasking, running multiple motors, required very complicated assembly language programming. It could be done, but it can't run it as fast as this. And it couldn't run as many motors as I'm running. The first animation I'm going to show is the head animation. I do that by pressing the button 7 right on the top. So if I press that, you can see the robot now moving the head animation, and I can still be driving it. See, I'm steering it. So this is an example of multitasking, multi-threading, and multiprocessing. It has 2 processors, a Raspberry Pi 4 and a VEX Cortex microcontroller. They're all communicating together. Now I can also be extending the arm. You can see the arm extending, and then I can retract it. You see the arm retracting. So that's quite a few motors running all at once. Now I'll do the wrist rotation by hitting 8 right. Now it's rotating the wrist. And it's pivoting it at the same time. This is a close-up of the Raspberry Pi LCD/touchscreen. Using the touchscreen, you'll be able to select all the original functionality of the original Hero 1 robot. Like you could use 3-1 to home the motors and home all the motors. You could use the learn mode, etc., and be able to use the original keypad functions. The experimenter board is also available for users to be able to prototype different circuits, which could be connected either to the Raspberry Pi 4 GPIOs or to the VEX Cortex. This would be useful like for adding additional sensors and additional hardware to the Hero 1 robot. The wrist and the arm motors, actually all the stepper motors on the Hero 1 robot have been rewired from their original configuration, which was unipolar stepper motor configuration, to a bipolar stepper motor configuration, which provides more power to the motors and allows me to use 3D printer technology to control the stepper motors. In addition, the 3D printer technology allows me to microstep the motors, so I could have the wrist rotate in up to 1/32 of a step. So you'd be able to go to a fraction of a degree, and the stepper motors, for the most part, are geared down using gears, so you'd even be able to get more precision. Right now, that functionality of microstepping the motors, although it's available, right now it is only available using jumper switches. So you could theoretically get the 1/32 of a step by putting 3 jumper switches for each motor. Right now it's on the single step configuration, which is the lowest resolution, but it's also the fastest, which gives you more realistic motion that on the Hero 1. Very similar to what the original. Actually, it's a little bit faster than the original Hero 1 robot. All the motors move much faster. I've had to intentionally slow them down a bit. A future upgrade kit will allow us to configure the stepper motors via the microcontroller. So they'd be software controlled, very similar to what the Arduino microcontrollers do with 3D printers. Right now, like I said, it's hardwired using jumper switches. As you can see, the Hero 1 is very responsive. I'm going to show the gripper animation. If I press the button 8 up, oh shoot. And again, I can be moving the robot around. You can see how fast the robot can respond.